So we're going to solve some equations, but the difference now is that we're going to have to write the equations first based on a scenario that we're given. And so there's some steps that we're going to follow. First step says identify the variable. So you need to read the question. The question is going to ask you to find something. You need to know what that something is. That's what you're trying to find. So you're going to choose a variable. A variable can be any letter to represent that thing that we were being asked to find. So that's step one. Read the problem. What are you asked to find? Choose a variable, a letter, to represent that unknown quantity that you're trying to find. Then once you've got that done, you're going to determine the equation. Based on what you're given as far as a description, you're going to write an equation to represent that scenario. And then you're going to solve it. As always, we want to check our solutions. And then finally, write a concluding statement. So those are the steps that we're going to follow. Looking at problem one, says that Dan is loaded. He's got $425 in his wallet. He has 5 more $5 bills than the number of $20 bills. How many $5 bills and $20 bills does Dan have? I'm sure this is something that you've always wanted to know. So we're going to find out. Now we're asked to find two things here. How many $5 bills and how many $20 bills? That's what we're asked to find. But we can only have one variable. Okay? In Math 10C, if you go on to take that, you'll look at some scenarios where you are going to solve equations with two variables. But we're not there yet. So right now we're just going to solve equations with a single variable. And the way that works in 10C is you actually get two different equations with the same two variables, and then you'll learn how to work with those two equations to solve for both variables. But that's in 10C. In this course, we're just doing equations with single variables. So even though we're asked to find two different things, the number of $5 bills and the number of $20 bills, we can only have one variable. So let's see how that works. What you need to look at is you need to look and see that one thing is compared to the other. In this case, we are told that he has 5 more $5 bills than the number of $20 bills. So let's just say he had 10 $20 bills. Let's just say that. How many $5 bills would he have then? 15, 5 more, right? If he had 21 $20 bills, Taylor, how many $5 bills would he have? If he had 21 $20 bills, how many $5 bills would he have? Because he has 5 more $5 bills than $20 bills. So if he has 21 $20 bills, how many $5 bills would he have? Can you help Perlina? 26, 5 more, right? That's what it says. So no matter how many $20 bills he has, the number of $5 bills is always 5 more. So the number of $5 bills is compared to the number of $20 bills. I'm going to choose a variable. Let's say let T equal the number of $20 bills. Taylor, do you have your package? Okay, you copy this stuff down? So because the number of $5 bills is compared to the number of $20 bills, I'm going to let T equal the number of $20 bills. So we just finished saying, if there are 10 $20 bills, there'd be 15 $5, 5 more. If there were 21 $20 bills, there'd be 26 $5 bills, 5 more. So if T is the number of $20 bills, the number of $5 bills would be T plus 5. 5 more than the number of $20 bills. So T plus 5 will be the number of $5 bills. So this is the setting up the variable part. Now, to solve the equation, well, first we need to write an equation. This is where we're going to use the fact that he has $425 in his wallet. Each $20 bill is worth $20. So if we wanted to get the value of all the money just from the $20 bills, we would take the number of $20 bills, which is T, and multiply by $20 for each bill. So that would be 20T. Plus, if we wanted to get the value of all the $5 bills, we would take the number of $5 bills, which is T plus 5, and multiply that by $5, because each of those bills is worth $5. And when you work this out, you're going to get the total amount of money in Dan's wallet, which is $425. That's our equation. So you're going to see that we're going to be given like two pieces of information for these. One of them will be comparing one thing to another, and normally we'll use that to set up our variables. The other part will be, okay, what is the total? And that's the part that we're going to use to actually write the equation. So now we have an equation with only one variable. We can solve it. The first thing you would do is multiply out the bracket. We'll combine our like terms. We have 20t plus 5 more t's gives us 25 t's. So we've simplified the equation that now we will solve. We'll subtract the 25 from both sides to get the 25t by itself. On the right side, 425, take away 25 is 400. And then to get the t by itself, we would divide both sides by 25. On the right side, 400 divided by 25, I think, is 16. Yeah. So what did we just find, Courtney? Can't hear you. How many, what kind of bills? Because there's two different types here. $20 bills, that's right. T is 16, and T represents the number of $20 bills. So Charlie, how do we get the number of $5 bills then? No. Jan? You add 5 to the 16. There are 5 more $5 bills than $20 bills. If there's 16 $20 bills, the number of $5 bills is 5 more. It's just a coincidence that it's 5 more, and then the value of that is $5. That part is just a coincidence. Right? They could have said there were 6 more $5 bills than 20, and you would have done exactly the same thing, except it would have been T plus 6. Okay? So there's our answer. Now, we want to check it. Now, to check it, we came up with our own equation. So I wouldn't necessarily use the equation that we came up with in order to check it. Because if we came up with the wrong equation to begin with, our answer might check, but it might not equal what it's supposed to equal. You've got to match the scenario. So to check this, there's two things that we need to look at. Number one, there has to be $425 in his wallet. So to check this, if we take 16 $20 bills plus 21 $5 bills, that should equal $425. So this is going to be part of our check to make sure that we get the right amount. So 16 times 20, I think is 320. 16 times 20, yep, that's 320. Plus 21 times 5, I think is 105, but let's check that. 21 times 5, yep, 105. And if you add those together, you're going to get 425. So that part checks. We've got the right amount of money. The second part we want to check is to make sure that he has 5 more $5 bills than $20 bills. So this is the second part of our check. Number of $5 bills subtract number of $20 bills has to equal 5. He has 5 more $5 bills than $20 bills. So if we subtract them, the difference must be 5. We found 21 to be the number of $5 bills, 16 to be the number of $20 bills, and that does equal 5. So there's our check. Both scenarios are satisfied. So we know our answer is correct, and we would write a statement that Dan has $21 $5 bills and 16 $20 bills. Okay, so there's the first one. Number 2, a little bit different. It says the sum of 3 consecutive integers is 126. What are the integers? So we're trying to find out what these 3 integers are. Integers are positive and negative counting numbers. No decimals, no fractions. And if they're consecutive, that means one after the other. So if 1 would be the first integer, the next would be 2, the next would be 3. If 20 was the first integer, the next would be 21, the next would be 22. If negative 9 was the first integer, the next would be negative 8, then negative 7. Consecutive means one after the other. We're told the sum of these 3 integers is 126, so that part is going to be for the equation. We first have to set up our variables before we can write our equation. This is how this would look like. I'm going to choose a variable. Let's say a equal the first integer. I could use any letter I want to represent the first integer. I just chose to use the letter A. So I said, if 10 is the first integer, the second one would be 11. It's one more than the first. So if A is the first integer, what's an expression for the second one? Beckham, A plus 1, absolutely. One more than the first. So A plus 1 would be equal the second integer. What about the third one, Kira? What do you think? Yeah, 2 more than the first. Or 1 more than the second. If you add 1 onto the second, the 1 plus 1 will give you the 2. Do we need to do any more? Do we need to do any more, Princess? Why not? Because there's already 3. And we're told that we're taking the sum of 3 consecutive integers. What does sum mean, Brooklyn? What does the word sum mean? That's product. Yes, sum means to add. So if we add these three together, a plus 1, and a plus 2, what do they equal, Hannah? What should we say they equal? Close, but what do I put on the other side of this equation? Yeah, the sum of the three consecutive integers is 126. So you added the 1 and the 2 together to get the plus 3, but there are 3 a's that are also being added together, which is 3a. Remember that the powers only change when you're multiplying or dividing. Here you're combining like terms. If you have 1 of something, you add another one, now you have 2. You add one more, now you have 3. So 3a equals 126 is the equation now that we're going to solve. And Kiana, how do we solve that? How do we get a by itself? Want to bet a pop on that? Okay. Is she right? We had it right the first time. Because the 3 and the a are hooked together by multiplication. So we will divide both sides by 3. So the 3's on the left cancel. And a will equal, I think, 42. But let's check. 126 divided by 3. Yes, 42. So what does that tell us, Princess? What does that tell us? That's right. The first integer is 42. Lucas, what's the next one going to be? Okay. Callum, what's the next integer going to be? No? Arpit. I did? What did I do wrong? Sorry? Ah, you're right. I did. Well, thank you so much. Thank you. We would have figured that out when we did our check. But thank you. It should have been 3a plus 3 equals 126. Thank you. So now we will subtract the 3 from both sides. And now we have 3a by itself on the left, giving us 123 on the right. And then we would divide both sides by the 3. And now we can say that a equals 41. Let's just check that. 123 divided by 3, 41. So now we found a to be 41. So now what's the next number, Arpit? Which is? And then, so that should be our 3 integers. Now, they are consecutive. That's the first thing. Okay, so if we're going to do our check here, the first thing is that they have to be 3 consecutive integers, and they are. Consecutive means one after the other. So we'll put a check mark besides that. And the second thing is that their sum has to be 126. 41 plus 42 plus 43 must equal 126. So if we get our calculator and we add those together, they do equal 126. So there's our check. The 2 different conditions have been met. They are consecutive integers and their sum is 126. Number 3. So we've got two different things being mentioned here. We've got the length and the width of a rectangle. Jackie, put your phone away. The length and the width of a rectangle. But we can only have one variable, all right? But we are told that the length is 3 times the width. The length is 3 times the width. So Christy, if the width was 10, what would the length be? 30, 3 times. If the width was 15, the length would be 45, 3 times. So in each case, the length is compared to the width. So I'm going to choose a variable, w, to equal the width. So what would an expression for the length be? What do you think, Ava? Okay, we said that if 10 was the width, the length would be 3 times 10, 30. If 15 was the width, the length would be 3 times 15, 45. So if w is the width, what's an expression for the length? That's okay. Yes. Width times 3 or 3 times width, 3w. The length is 3 times the width. So if w is the width, the length would be 3 times that, 3w. So we've set up our variables. Now we're told the perimeter is 96. What's perimeter, Jace, of an object? That's right, you're going to add up all the sides. It's the distance all the way around. So if it's a rectangle, there are 2 lengths and 2 widths, right? So to write our equation, 2 widths plus 2 lengths, that's our perimeter, must equal 96. So there's our equation. The perimeter is the distance around. You add up all the sides. Now, if you wanted, instead of going 2w, you could go w plus w. And instead of twice 3w, you can go 3w plus 3w. It doesn't matter. But you're adding up all 4 sides. So 2 times 3w is 6w. When you add the 2w and 6w together, you'll get 8w. And now we will divide both sides by 8 to get w by itself. So 96 divided by 8, I think, is 12. Yep. So Kate, what did we just find? What does W represent? That's right. We found W to be 12, and W represents the width. So Jackie, how do we get the length? What does it say that the length equals at the top? Yeah, multiply W times 3. So the length would be 12 times 3, which is 36. So we're saying that the width is 12, the length is 36, and that will be in centimeters because our perimeter is in centimeters. But to make sure, we'll check it. So the first thing that must happen is that the length is 3 times the width. And so in this case here, the length, which is 36, must be 3 times the width, which was 12, and 3 times 12 does equal 36. So that checks. The second condition is that the perimeter must be 96. 96 centimeters. So if we have a 12 centimeters plus another 12 centimeters plus a 36 and another 36, that should equal 96 centimeters. So we'll get our calculator out. 12 plus 12 plus 36 plus 36 does equal 96. So that checks as well. And we'll write a concluding statement. We want the dimensions of the rectangle. So we can say the rectangle measures 12 centimeters by 36 centimeters. So there's our answer. All right, number 4 is similar to the first one where we talked about the money in Dan's wallet, except that of money in a wallet, it's money in a parking meter. There are only quarters and dimes in there, and there's a total of $27.05. The other thing we are told is that there are 146 coins. So a little bit different than Dan's wallet, because in Dan's wallet, the number of $5 bills was compared to the number of $20 bills. So it's a little bit different, but the principle will be the same. Because the number of coins, or quarters I should say, is not compared to the number of dimes, or the number of dimes is not compared to the number of quarters, it doesn't really matter what variable we start with. We need to choose a letter to represent either quarters or dimes, because remember, we can only have one variable. So for no reason, because it doesn't matter either way, I'm just going to choose D to represent the number of dimes. There are only dimes and quarters in the parking meter, so it has to be one of those two. And I don't have to necessarily use D for dimes. I could use A for dimes, or Y for dimes, or P for dimes. It doesn't matter. Did you sign in, Keen? Okay, now we need to write an expression for the number of quarters, but it has to involve D, the number of dimes. Okay, so on the side here, here's what I'm going to do, just to make sense of this. If I initially say right now that Q is the number of quarters, now when I write my equation, I can't have Q in there, unless that's my only variable. And I've already said that D is the number of dimes, so put that away. No, you're not. Put it away. So, as I do this, I only want to have D in my equation. But I am going to introduce Q right now to help me write an expression for the number of quarters in terms of D. So on the side here, I'm going to say Q plus D equals 146. Because the number of quarters plus the number of dimes has to equal 146. And if I want to write Q in terms of D, I'd want to get Q by itself. So what would I do to both sides to get Q by itself there, Beckham? Sure. I've got this equation here, Q plus D equals 146. If I want to get Q by itself, what would I do to that equation to get Q by itself? Q, yep. If you add D to both sides, you're not going to get rid of this D. We need to get rid of this D. Yes, you would subtract D from both sides. And now we have an expression for Q, the number of quarters, in terms of D, the number of dimes. If D is the number of dimes, we've just shown here on the right that the number of quarters would be 146, take away D. So from that, we can say that 146 take away D equals the number of quarters. Because we can only have one variable in our equation. We did introduce a second variable, but we used that so we could have an expression for the number of quarters in terms of the number of dimes. So there's our two expressions. Now, we'll write our equation. And it's going to involve the total amount of money that is in the parking meter. Each dime is worth 10 cents. So 0.1, which represents 10 cents, times D, the number of dimes, plus each quarter is worth 25 cents, or 0.25, times 146 take away D, equals 27.05. There's my equation. This represents Keen. You need to copy this down. Pardon me? This represents the value of the money in the meter. Each dime is worth 10 cents. So it's 0.1, which is 10 cents, times D, the number of dimes. Each quarter is worth 25 cents. So it's 0.25 times the number of quarters, which is 146 take away D. Now we have our equation. We need to solve it. First, we will simplify. I'll multiply out the brackets. So 0.25 times 146 is 36.5 minus 0.25D. Right, I multiply both terms inside the bracket by 0.25. That equals 27.05. I've got two D terms on the left, so I can combine them by subtracting. 0.1D take away 0.25D is negative 0.15D. And now to get D by itself, I'll subtract the 36.5 from both sides. So they'll cancel on the left. I'll have negative 0.15D on the left equaling negative 9.45 on the right. And then our final step, we'll divide both sides by negative 0.15. And that will cancel on the left. We have D by itself. And on the right, we'll do that division. And we get 63 for D. So what have we found, Ava? Yes, the number of dimes is 63. So let's write this over here on the left. And how do we now find the number of quarters, Brooklyn? Say again? I didn't hear you. That's right. 146 minus 63 would be the number of quarters. So 146 take away, whoops, try that again. Take away 63 is 83. So here's our check. First thing is that, and it doesn't matter which order we do this, but let's start with the fact there's 146 coins. Meaning 63 plus 83 should equal 146. So if we check that, 63 plus 83 does equal 146. So that part checks. And the second thing we need to check is what, Jan? That's right, the amount. What must the amount equal? That's right. The total amount equals 2705. So that's the second thing we need to check. So we found 63 dimes plus 83 quarters Each dime is worth 10 cents, 0.10. Each quarter is worth 25 cents, 0.25. So together those should equal 27.05. So 63 times 0.1 would be $6.30. 83 times 0.25 is 20.75. And if we add those together, we get our answer, 27.05. So there's our check. Our answers satisfy both conditions. So now we'll write a concluding statement. There were 63 dimes and 83 quarters. In the meter. Okay? So again, quiz on Monday on everything we've done so far on equations. So we've done one-step equations, two-step equations, multi-step equations, and now these problems. So remember that 4.2 assignment from this chapter is due for marks, plus the one we did yesterday. So if you weren't here yesterday, you need to come and get it at the front here. I'll hand out today's assignment, and I'll post the solutions on Google Classroom so that you can check your answers there. But there's going to be word problems on the quiz on Monday, so do the practice. Just put it there. Okay. Say that again.
I said I finished the one from
Okay.
yesterday, but I finished the one today.
Well, do you have it?
I wasn't here
Okay.
the following day.
I'll get it for you.
Yeah, it's so heavy.